Hello class. So in this video, we're going to continue on section 4.9. In the previous video, we saw how to define the indefinite integral of a function, right? So we saw that whenever we see this notation here, that means all antiderivatives of the function f on some interval, and it also means the indefinite integral of f of x on some interval. And I mentioned that for that second definition, as of now, it's kind of hard for us to understand, right? Because I mentioned the notation is still a little bit weird. In chapter 5, you'll understand why we call this an indefinite integral and why we use that notation. But for now, just know that that symbol means these two things. Okay? Now, here, the first thing to note is here I have the indefinite integral of the function x to the p dx. And here I use I actually typeset the symbol for the integral so you know how it actually looks like. Right? So I just draw it as a stretched out s, which it kind of looks like that, and that's fine. Right? You can just draw the integral symbol like a stretched out s like I do, and I'll understand what you're meaning. But if you want to see how it actually looks like, it looks like this. I don't remember exactly what the symbol is called, but that's how it looks like. So what is this theorem about? When we're taking derivatives of a function, we saw that there were some shortcuts, right? There were some formulas to find derivatives of a function. The same thing is true for finding antiderivatives. Okay? And that's what we're going to see here. So the power rule for indefinite integrals. If you want to find the indefinite integral of x to the p dx, remember this is the same as asking what are all antiderivatives of x to the p. What do? You add 1 to the exponent and divide by that exponent. And of course, add c, right? Because all antiderivatives have a form of one specific one and then add a constant. Now here, it's kind of clear that we can see how taking the antiderivatives is the opposite of derivatives. Because if we were taking the derivative of the function x to the p, what would we do? Well, we would bring down, multiply by the exponent and subtract 1. Here we can see we're doing the complete opposite thing. Instead of multiplying, we're dividing by the exponent. And instead of subtracting, we're adding 1 to the exponent. Okay? So you can see that it's really the complete opposite of what we do when we take derivatives. Right? Now, there's just one caveat for this theorem. This doesn't work when p equals -1, meaning that if we want to find the indefinite integral of x to the -1 dx, which is the same as the indefinite integral 1 over x dx, we still don't know how to do this, right? We can't do this here. This formula doesn't work. But for any other exponent, it works. So let's see it in practice. So find the indefinite integrals of the following. Okay? So we want to find for a, the indefinite integral of z to the -z. Now here, I want to point something out. Whatever variable you're using for the integrand, right, so whatever variable you're using for the integrand has to be the same variable that you use here. And again, that's kind of weird why it is like that. It's going to be made clear in chapter 5. For now, just think, okay, whatever variable I'm using in the integrand, it has to be the same variable in the after the d. Right? So if I'm using z as the variable in the integrand, I want to use dz. So what is this by definition? Well, let's just look at the previous theorem. It says add 1 to the exponent and divide by the new exponent. Okay. So we're just going to add 1 to the exponent. So -7 plus 1 is -6, and divide by that new exponent. And that's all antiderivatives of z to the -z, to the -7. So very straightforward. Now let's do part B. Let's actually use another color. So part B, want to find the indefinite integral. So use this notation. Again, remember, for this indefinite integral, think all antiderivatives, it means the same thing. So I want to find the indefinite integral of z to the, oh, this should be s, because I'm using s as the variable. Small s. Yeah. So I want to find the indefinite integral of s to the 1011. And again, ds, because s is the variable we're using in the integrand, by the previous theorem, add 1 to the exponent, so that would be 1012, and divide by the new exponent, and then of course always add the c, because we're looking for all antiderivatives, so we have to add that c, and that's it. It's so very simple.